here, or you can hit that and it will advance it to the next slide.
Got it. Okay, well, good afternoon, everyone, and thank you very much for joining us. My name is Chuck Caughey. I'm a geologist, and it's my pleasure really to be here this afternoon telling you about careers in geology. I am a petroleum geologist, and this is one of mine. This is a gas discovery deep in the rainforest of Sumatra. There are still jobs in energy, for sure, but there are jobs in many other fields. Geologists are needed to develop, protect, and conserve groundwater, to detect and prevent earthquakes, to ensure safe construction of buildings and highways, and much, much more. We'll visit some of the places that I've worked to see what geology embraces, and then we'll look at critical needs for geologists, some of the many jobs that are available, and the education these jobs require. Many geologists like me have done a lot of travel associated with the work, and we'll look at some of the advantages and challenges associated with living and working abroad. I encourage you to all continue your education, and I will close by showing you a brand new scholarship that we have for transfer students that apply to graduates of San Jac. You can apply for a full ride, all costs paid, for your last 2 years to get a Bachelor of Science in Geology at Sam Houston State. So fasten your seatbelts and let's get this underway. We're going to start at one of the largest oil and gas fields in the North Sea. If I can figure out which arrow to hit here. And I am not getting a response from him, JF.
There you go.
Okay. I'm standing here next to Omar Hamid. He is Chief Medical Officer for an Iraqi National Oil Company. Okay, he has responsibility for hospitals and many doctors and nurses, but he's also a practical doctor, as it turns out. Our translator became very ill. He went up to them and diagnosed him immediately with acute appendicitis. We rushed him to the hospital, and the doctors there say we saved his life. So he's that in addition. All right, so I'm out here in the middle of the North Sea. I'm equidistant from Scotland and from Norway, about an hour and a half in a ride in a fast helicopter. What am I doing out here? I grew up in Houston, the West Side and Spring Branch. I went to the University of Texas, and there I took an introductory geology course. That hooked me on geology. I landed a job that summer looking for gold and silver in the remote eastern mountains of Nevada. Wow, they pay people to do that? I thought that was wonderful. Went back to school, I was on my way, and then the Army came along. And I was drafted. 2 years later, I went back to the University of Texas, graduated with a master's, and I've been a petroleum geologist ever since, finding and developing oil and gas fields across the southern U.S. and in other places in the world. I've had the good fortune to travel to many places in the world, including the Middle East, which is where we will go next. And we're here to consider, what is geology? Geology combines all of the other sciences. It combines biology, chemistry, physics. You got to have a little bit of math. You got to have all these things in geology to understand what's going on in the world. We study the physical and chemical composition of the world. He said, there we go. It's the ultimate integrated science, physical and chemical composition of our planet. Cleo Proctor and I were out here describing rocks in the Gilt Kabir. We're in the far southern end of Egypt, right up against Sudan and Libya. To tell you the truth, we actually went into both of those countries, mapping rocks, looking for places to drill for oil and gas. But we also went down into the Sarir under here and looked at that. And down there, we were exploring the past to understand the present and sometimes predict into the future. Down there on the Sarir, we found a very large dry lake bed. It was surrounded by artifacts indicating that the people had lived around this lake for millennia, for thousands of years. Out here in one of the driest places on Earth, at least 100 miles from the nearest habitation, in a local oasis, the Karga Oasis. There's nothing out here now. And so we can really see that there's been some changes. And so there have been major changes in the Earth. And we can study Earth processes and changes through time. Okay, we saw one with this dry lake bed, but we also have seen major mass extinctions, including the Chicxulub impact crater impact about 65 million years ago that killed off the last of the dinosaurs and most everything on Earth. There have been 5 mass extinctions on Earth, and this is only the latest. There have been major changes throughout geologic time. Okay, geology is concerned with that, but also now astrogeology. Geologists study the moon, they study Mars, they study exoplanets. These are planetoid features that are detected in other solar systems. And so there's all these things that you can study. Getting back to life for a moment, the earliest life on Earth dates back to about 3 billion years. 3.2 is what I looked up before coming over here today. Well, right now, the Mars rover, I'm going to back up. We're going to look at what we had in artifacts around that lake bed. We have a grindstone down here. Look at the scale of 6 inches. A grindstone down here that you can fit in your hand and see how they were grinding wheat. This is having agriculture, so this is about 10,000 years ago. We also found much older artifacts that were chipped out, and these are called fist axes, but they're actually scrapers for hunters and gatherers who also had spear points to hunt. These are Paleolithic. They're 1 million years before now. So we have life around this lake for millennia and perhaps for longer than that. Okay, how long does life go on Earth? Well, as I was mentioning, back about 3.2 billion years. That's on Earth. What about on Mars? Well, let's look at that. This is the Mars rover, Perseverance, which is right now exploring Mars, looking for life on another dry lake bed, mind you. And the age of this lake bed is interpreted to be 3 billion years, about the same as the oldest life on Earth. These rovers, incidentally, are piloted by geologists. And we've had a geologist driving a Mars rover present to the Houston Geological Society a couple of times. Fascinating to me how they picked the sites, how they actually picked where this is going. And of course, for Perseverance, it's got this drone ingenuity to help it see where it's going. So there's geology in doing that, and perhaps some of those listening to me today might one day be driving a Mars rover, either remotely like this, maybe in person, okay? Okay, so let's go back to Earth. That's some geological needs, but let's look at critical needs for geologists. And for that, we're going to return to the rainforest of Sumatra. And here I am, I'm bird dogging seismic crew. What that means is field checking seismic acquisition. I'm looking for oil and gas, in this case at Aceh, which is the northernmost part of Sumatra. One of the problems I came across in Aceh and other places in Sumatra was CO2 that infuses itself into the gas reservoir. This makes it much less commercial. In a case here, the largest gas field, largest oil and gas field I found in my career, 10 trillion cubic feet of gas. Made the front page of the Oil and Gas Journal, made the Wall Street Journal. Wonderful until it tested 82% CO2. Wow, went up like a rocket, down like a rocket, okay? So what do we do about CO2? I studied carbon and oxygen isotopes to find out the origin of CO2 and find ways to avoid it. Okay, so there's ways to do that. In addition to that, so we're looking at critical needs for geologists. Bring that up, said, and I just talked about petroleum and CCUS, carbon capture, utilization, and storage. I have 2 friends of mine, geologists, one here in Houston, the other in Adelaide, Australia, working with CCUS. Carbon capture is done by pulling it out of the atmosphere or out of waste streams from oil and gas or from factories. Then it is injected into oil fields for secondary recovery, enhanced recovery, or simply disposed of deep in the subsurface. So here are jobs for geologists. Other than that, you might be interested in a nice, clean, renewable energy in geothermal. Geothermal, of course, hot rocks deep in the subsurface, usually in volcanic areas, heat water that flows to the surface and is used then to produce electricity and also to heat homes and businesses. And so there are jobs in geothermal. A former supervisor of mine was involved in this in Indonesia, developing geothermal fields and producing them now in 18 countries throughout the world, including, guess what, the US. And so there are jobs in geothermal. We can then go into a very important area of water. In some places in the world, water is much more precious than oil. Water is important throughout the world, and it's very important in many parts of the US. Right now, a major drought on the West Coast. We've seen all this in Texas. There are a lot of geologists working in water, working in groundwater hydrology, working in surface water. The geology of lakes is called limnology. We had a huge flood here a couple of years ago. There are geologists working on how we can reconfigure the rivers and bail the material out of lakes to avoid this in the future. Okay, beyond that, another thing that's important in geology is environmental geology. Gee whiz, I'm an environmentalist. I think most geologists are. You can get jobs in environmental geology, and we'll talk about that more briefly. First of all, I'd like to get another area that I've worked briefly, and that is mining. Mining employs many, many geologists looking for the ores, the minerals, the metals that we need in all throughout society. And so there are many jobs in mining, and let's go look at that at one of the most remote places on Earth. This is the island of New Guinea. And you can come with me up this, okay, sorry about that. That mining geology was oriented right here to take you up the cable car. It doesn't matter. Right up the cable car at 16,500 feet. They have oxygen up there, and several of us needed it. You're looking up to the Carstens Glacier, one of two equatorial glaciers right on the equator. Look down and you see a huge mine, which is the second largest copper and gold mine in the world. There are many, many geologists out there drilling core holes, describing the core, pulling their data together, or mapping the surface geology using remote sensing methods to find new veins. Gold and silver and copper are even more important now that we need them for the panels that power electrical vehicles. Now we're having more electrical vehicles, we need these. We also need lithium and boron for the batteries associated with this. And guess where lithium and boron come from? China. So we have new battery plants that are opening now. They're scrambling to find geologists to go find the materials that they need. So there are lots of jobs in geology, and in terms of working in mining, you're working in the field. What's it like to be in field geology? Okay. Field work now is usually GIS based, and you're using GPS, drones. LiDAR is a laser method of measuring distances in great detail, and it's used because you can do it very quickly. You can map outcrops very, very quickly and in tremendous detail using LiDAR. Drones are used, satellite, magnetics. I've flown magnetic surveys, I've used gravity. I've shown you that I use geochemistry routinely. I've been involved with seismic acquisition, most of the things on this map, and I really do enjoy doing that and getting off into the field. Okay. Being in the field, you're getting close to nature. And here is something that I came across, staking the location for that first slide. This is a tiger paw print. A tiger paw print that's about the size of your hand. We found this when we were staking the location. The roughnecks on the rig, when we were drilling the well, saw the tigress. It was a big female tiger. They told me, Chuck, you got to quit running through the rainforest here. It's not safe. Staking the location, we were also stepping around large mounds of elephant dung. All right, we're doing that, looking for the benchmark that marked the location. We couldn't find it anywhere. I asked surveyor Darwies, who was there with me, I said, okay, well, come on, Darwies, what happened to the benchmark? I said, the elephants like to scratch themselves on it. They must have taken this one with them. Okay, so there is nature involved in that. Let's then look at environmental geology. This is a map, this is a page from a 1988 sheet in the Houston Chronicle describing surface faulting in Houston, Texas. You can see surface faulting pretty much all over the city. Most of it in the south associated with the salt dome, but much more off to the north. This is associated with normal down to the coast subsidence of the coastal plain. It's also exacerbated by groundwater production that causes subsidence. And so there is slow movement on these faults. We're not seeing earthquakes on them. It's just very, very slow movement, but it is significant. I grew up in Spring Branch. Here is a home in Spring Branch. And I went out there myself a couple of years ago, and it's much worse than this was in 1988. I walked up the driveway. I don't know if it's his house, but walked up the driveway to the house where the fault scarp. The garage is 2 feet above the end of the garage, end of the driveway. Go around on the other side of the road, you walk up the driveway, the garage is 2 feet below. It's on the downthrown side. So major structural problems. So geologists are involved in environmental geology and in construction. They're concerned with construction of homes, buildings, dams, I've shown you Houston, but this is a situation throughout the country. You know, geologists are necessary to sign off on power plants, dams, now highways. I know a man whose job is looking at road cuts to be sure that they will not collapse on the highway. Works for the highway department. That's his full-time job. The geologists also are involved in working with groundwater pollution, which is a major thing right here in Houston, Texas. A couple of days ago, the Chronicle online carried a story about an area in the Fifth Ward that had been a train station. The creosote railroad ties have seeped into the ground, and now they're going to have geologists come in, drill holes, monitor the groundwater in the area, and see what they can do to remediate it. So there are big jobs in groundwater. In addition to that, the environmental geologists are concerned with hazards, with predicting and mitigating floods, landslides, earthquakes, volcanoes. Radon comes into homes in some parts of the country, not in the coastal plain here in Texas, but where granite is exposed, towns and subdivisions built on granite have the problem of radon seepage. So there are many other things. Beyond that, oil fields and also businesses produce large volumes of liquid waste. What do we do with it? What we do is we store it deep in the subsurface where it's safe, well below the groundwater where it will not ever come back. We need geologists to handle all of that. So many jobs in groundwater and environmental geology. Okay, so what do you do about these? Well, how can you prepare for them? One of the things you need to understand is that most geology is worked in the office. I've been to the field in many places doing many things, but most of my time is spent at a desk, sitting in front of a computer or a workstation working. And so that's it. And if you want to prepare for one of those jobs, you need to have computer skills. This is a friend of mine, Ali Yaqub, sitting at a seismic workstation and working. If you're looking for a job, and even if it's not in geology, I do encourage you to get all the computer skills that you can. You'll find that they expect you to be handled Word, spreadsheets, PowerPoint, or other presentation software, and that you can gain experience working on a seismic workstation, get that as well. So that will help you. Where are you going to go look for jobs? What if you don't have 4 to 6 years to attend college? Where do you look? There are technical and administrative jobs. You can work in the office, you can work in the lab, or you can work in the field. Office jobs, collecting and processing data. Resource companies generate mountains of data. Golly, I've done this, and I've had technicians help me acquire and process the data. There are jobs with oil companies like I had, there are jobs with government agencies, there are jobs with companies that just manage data. There are two huge ones, Petroleum Information and IHS, Information Handling and Storage. Hire early career people like that to help them process the data. In the laboratory, sample processing of what? Cuttings from wells, core, all the things that are brought in, water samples, oil samples, gas samples, and you're going to be describing them and analyzing them. In the field, you're collecting these samples. I have sent technicians to the field to get oil samples, gas seeps, which I had a slide to show you what those look like, cuttings from wells, rocks, all kinds of things to bring them in. In addition to that, there are field jobs in working on seismic crews, which I have done, drilling rigs, very important in health, safety, and environment, GIS, which is surveying. And then if you come into the office, you can work as a technical assistant. That is a technical assistant for a geologist like me, for a manager, an engineer. And geotechs work in the office. They also work in the field. Some of them do both. As an example, my associate, Randall Scott, was working with me here in Istanbul, Turkey. And we're on the patio of the Hilton Hotel in Istanbul. If you look out there, you can see the Bosphorus Strait behind us. What are we doing? We're working with Iraqi engineers, showing them how to use Trimble GPS gear. It's amazing stuff. In a couple of minutes, you can locate a spot on the earth to within about ½ an inch. Okay, these Iraqis then could actually build facilities with this kind of gear. I didn't need them to do that. I needed them to locate wells, which in some cases were mislocated by 1 kilometer or more. So there are all these kinds of jobs. Where do you go looking for these jobs? What can you do to go find these jobs? Start online. What are you looking for? Oil companies, big and small. Service company, Halliburton, Schlumberger, also local service companies. Many government jobs, U.S. Geological Survey, the Bureau of Economic Geology, Water Development Board. There are many other government agencies that will hire you. And very important to finding a job, get involved with technical societies. I'm a member of the Houston Geological Society, and I do encourage you to do that. They're just about to where they're going to start having meetings in person again. Go to the meetings, meet people, tell them who you are and what you want. And that's a good way to get a job. And I'd be happy to tell you individually of some personal stories of how that's worked for people. Most important, meet people and network. You go out, you look online, you send out letters, you try hard, you call people, but the way you're going to get a job is by meeting people. And so I do encourage you to do that. Okay. What if you go ahead and get a job as, what if you go ahead and get a Bachelor of Science degree in geology? What can this do? What's the uplift for that? Now you can be a professional geologist or a professional geophysicist. One of the places many geologists start right out of school is in well site work. You'll find that when you're a well site geologist, you're the most important person on the rig because you're the person that can actually see into the ground. You know more than anyone else what's coming up. A very, very demanding position, one that's important. In addition to that, you can be a science teacher. I've worked with science teachers lecturing to middle school and high school kids in classrooms. I've taken them on field trips. I've also taken the teachers on field trips, and they do very, very important work. You can work as a geotech, as we've described before, or you can continue studies for master's or PhD. Why would you do that? Why would you do that? Let's go to the Roman city, the ancient Roman city of Philadelphia. Maybe ask the Oracle, why should we be going after advanced degrees? This actually is downtown Amman, Jordan now. You can see some infrastructure in the background. We're turned around the other way, you see buildings and roads. Okay, why would you get an advanced degree? Well, let's look at a bachelor's degree. It's going to take you, a master's degree is going to take you another 2 or 3 years. For me, it was 2.5. Hey, I was in the Army, what can I say? But typically a total then of 6 to 7 years of college. What does it do for you? Now you can hire as a senior geologist. As a recruiter, 4 or 5 years ago, I was hiring people right out of school with a bachelor's degree for more than $100,000 a year, bringing right into very, very important jobs, hitting the ground running right out of school. You can also be a community college lecturer, something that I really have a whole lot, really a warm place in my heart. In fact, to the point where this is something that I have considered myself. I really do think they do a great job. It's a challenging position and a very important one. All right, what if you go on from that? What if you go on for the very best? What if you go on for a PhD, the top level that you can get? All right, what is the story of that? Now you're looking at 8 years of college, 4 years for the undergrad. Boy, where I went to school, 4 years or more of graduate work. It's a lot of work. Why do you do that? Well, it does open some doors. You could be a university professor. You can also work as a research scientist. Exxon Production Research. Again, the Department of Energy, the USGS. These are things that you can do. I worked with a lot of PhDs in my career just doing the same things I was doing. Why did they have a PhD? It took them to the top. It took them to the absolute limit of professionalism. And so I understand the personal satisfaction of doing that. To me, I think that even outweighs the additional job opportunities. Okay, so we've done all these things. Is anybody interested in the money? Or what money you might make as a geologist? No hands went up. Well, maybe we'll skip this. Oh, there was a hand that went up. All right. What are geological salaries? This is from the Department of Labor. It's dated May 2020. It's the latest data that we have. I really do expect that these salaries have gone up along with other salaries. COVID years, we've had a rapid increase in salary. And what are we looking at? Looking at median salaries, that is 50% make more than this, of over $90,000. And if you look at an average annual salary, a little over $100,000 a year, average for geologists. Okay? The bucks are good, they really are. All right, well, where are these geologists working? I mentioned a lot of different things, and here's a listing of some of them. This is the way the Department of Labor breaks it down. Oil and gas extraction, the most people and the most money. And these numbers are good. These are reasonable expectations. You can see mining as well, others. The architectural, engineering, and related services, there's something wrong here. I don't understand that. If you look at this, it says down here, except hydrology. I did look up hydrology. Hey, I trained as a hydrologist myself. They make about $1 an hour less, not a big difference. So you can do all right as a hydrologist as well. Okay, so the money is all right. Really, I think most of us would agree with that. And all right to actually, in many cases, very, very good. There are very wealthy people that have got through geology. But what about some of the other benefits? I've shown you slides of places that I've been, and this is only a small part of it. I don't claim to have traveled the globe, but there are a lot of people who travel more than I have, but I really have enjoyed going to places I have gone. So travel is what I consider to be one of the additional benefits. And let's go here. This is Mount Nebo. I'm looking out over the Dead Sea, actually looking the other direction, but this is the Mount Nebo overlook over the Dead Sea into Israel in that area. It's where Moses is said to have stood. And I'm here to consider what are the advantages and some of the challenges associated with international travel. We'll start in Egypt, where I started. I'm standing on the busy Corniche freeway. It really is downtown Cairo. It's actually the suburb of Mahdi. You can see the Great Pyramid here in the distance. This is the Nile and some of the felucca boats that are on it. The Sheraton Hotel is just out of sight to the right. We really are downtown Cairo. And what are some of the advantages of living and working overseas? What are the advantages? Well, one of the big ones is a new culture and new friends. The change in culture can be amazing. I think you will really be astounded. One of the things that I remember from my own high school was that our senior trip, I was in high school at Spring Branch, and the senior trip then took us to Austin. Okay, my son Ian, we're there in Jakarta, Indonesia. His senior trip went to see the Taj Mahal. So there really are major advantages like that with being overseas. Yes. In addition to that, the technical aspects. There we go. Exciting work. Exciting work is exactly right. You will be working with amazing projects, or you can be working with amazing projects. These may be breathtaking in size, scope, and technical challenge. Higher levels of responsibility are required, where you not only need to know how to do everything, you're expected to train somebody else, a national employee, to take your job. Beyond that, lifestyle and travel. Wow, I've shown you some travel. Lifestyle. Gee whiz, many places you have household staff. I had 5 in Indonesia. You have a driver. The clothes that I wore today would be washed, ironed, and in my closet when I got up tomorrow. You like iron sheets? You know, that aspect is really pretty nice. Beyond that, compensation and benefits. This is last on my list, and I think it really deserves to be there. The typical uplift in salary is 5 to 40%, depending on where you are. Don't expect to get wealthy, because you will have additional costs associated with keeping your standard of living where you are. Travel expenses will be higher. And so it's nice, but don't expect to be wealthy. And like I said, it's last on my list. It's still significant, but not most important. Okay, those are advantages. What about the challenges? Okay, you will not be posted in all likelihood to a desert camp, a Bedouin camp like this one, which is near Madaba, Georgia. But nevertheless, it's good to look ahead and see what kinds of things you might be facing. Uh-oh, I might need help getting that back on. I hit the wrong button. Sorry about that, JF. Thank you, sir. What are the challenges? Culture shock is the first one. And culture shock is very real. Culture shock is being in a environment where you may be surrounded by people, but they all look different than you. They all talk different. You can't tell what they're saying. They have a different religion. They're all a different color, maybe. They're all different. They're people coming up and just touching you. You can be surrounded by people and feeling very, very, very lonely. It is significant. Beyond that, medical issues. Medical services may be very different than they even be lacking. I was very fortunate that my wife was a nurse, and she was a medical authority for the people that I worked with and for my neighborhood. And there may be diseases that you're not familiar with that are endemic: malaria, dengue fever, cholera. There are other things that you have to deal with and keep yourself and your family safe. Personal security is a major issue, and that no place on the world is safe right now. However, stress is higher if you're in a situation where there's security checkpoints, searches, and alerts. So you've got to be aware of that. Beyond that, what about personal and family concerns? Well, this is much easier now with cell phones because, gosh, you're connected 24/7. Your kids have cell phones. You can call, you can text, you can maybe even video. There are places in the world where those are not connected. You might consider that for one thing. But beyond that, there are real family concerns. These would include standards for schools and child care vary widely depending on where you are. So check that first. Spousal work or your significant other may not be able to work, and their activities may be much more limited. Beyond that, access to consumer goods will be different. Expect that, and it may be harder than possible to find the familiar items that make your life comfortable. The food, the toiletries, those kind of things. Everybody has to eat, but they may eat very differently than you do. Nevertheless, I've found that these are really, really wonderful advantages, and I found all those challenges very acceptable. I have friends around the world. I have friends from many different cultures, and I thoroughly do enjoy it. This is, incidentally, this is Petra. It's in southernmost Jordan, and these are funerary structures that are carved into Cambrian sandstone. Cambrian's about 549 years old, okay? It's geologically significant because the Nabateans that lived here held off Alexander the Great's generals. They held off the Roman legions from 400 BC to 100 AD. How did they do this? Because there are fractures in this Cambrian sandstone, and to enter Petra, the only way in is a narrow canyon where you can reach out and touch the sides, just like on both sides with your hands. They were able to hold off Roman legions by fighting them one man at a time. How did Petra fall? The Romans cut off their water. Okay, geology again. Had the Nabateans developed groundwater, they might still be there today. Okay, a couple of comments in closing. Whatever you do, wherever you go, to me, the most important thing for success in your work is find something that you're good at, that you enjoy. Far more important than where you are, far more important than the money that pay you. I do encourage you to continue your education. It will pay off, no question about it. And in closing, I will show you for junior college students, for community college students, definitely for you here at San Jacinto, a brand new scholarship at Sam Houston State University. It requires a 3.0 GPA, get enough credits to enter as a junior, get 2 years of junior college credits in science, and enter there. All costs paid for your 3rd and 4th year studying geology at Sam Houston State. All costs, tuition, fees, room and board, everything. And so I'm really looking to see Sam Houston select a candidate. I'd love it if it's right here in San Jac to get on with your career. With that, are there any questions? Thank you very much. So does my audience here have any questions?